All right, so section 11.4, we are simplifying rational expressions. Right? And so if you think back to when we learned about rational numbers, a rational number is just a number that can be written as the quotient of two integers, or otherwise known as a fraction, right? So it can be written as a fraction, 1 over 2, 4 over 3, 7 over 1. Any number that can be written as a fraction is called rational. So if we're talking about something called rational expressions, we're talking about expressions that are written as a fraction, right? The numerator and denominator both are non-zero polynomials. So if it's a rational expression, it's a fraction that has polynomials built into it, either in the denominator, the numerator, or both. So 3 over x plus 4, 2x over x squared minus 9, 3x plus 1 over x squared plus 1. All of those are examples of rational expressions. Now, sometimes a rational expression is possible that we could simplify it just like any other fraction. And what we have to keep in mind is, if a, b, and c are non-zero numbers, if I have a times c over b times c, right? Or some number is made up of two factors, but they both share the same factor, a times c, b times c, then we can cancel out the c's and we just end up with a over b, right? Just like if we have 28 over 35, 28 is 4 times 7, 35 is 5 times 7, so the 7's would cancel each other out and we'd end up with 4 over 5. So same rules can be applied if we have a rational expression with polynomials inside. So anything that multiplies together, if we have the same term multiplying top and bottom, then we can cancel it out. So 5 times 3 minus x over 5 times x. Both the top and bottom will be multiplied by 5. So we can cancel the 5 out. That's going to leave us with 3 minus x over x. Now, since this x is in a subtraction, and this one is not the exact same subtraction, then we can't cancel out the x here. We can only cancel it out if it's in a multiplication, in a product. So, next one, 2x squared over x times x plus 5. 2x squared is the same as 2 times x, right? X squared is x times x. And that's over x times x plus 5. So 1x, we have 2 x's up here, we have 1 down here, so 1x down here can cancel 1 up at the top. And we're going to be left with 2 times x over x plus 5. And we can't go any further than that because this x is in an addition. All right, next one. 5 times x plus 3 and x plus 3. I know one thing that a lot of people would be tempted to do is say they see an x plus 3 here and an x plus 3 here, to cancel those out. But since we have a 5 right here, and we can't factor that to where it's 5 times x plus 3, then this expression is not the same as the expression on the bottom, and we can't simplify that any further. So it's going to stay 5x plus 3 over x plus 3. Next one, 15x over 5 minus 10x. So 15x on the top, can't really do much with that. 5 minus 10x, 5 and 10. Both of those terms would divide by 5. We could pull a 5 out of those, in other words. So we can have 15x over, if I pull a 5 out of there, 5 divided by 5 is 1. 10x divided by 5 is 2x. And then we have 15 over 5 that are both in multiplications or in products. So we can actually divide that. So 15 divided by 5 is 3x over 1 minus 2x. That's going to become 3. That becomes 1, right? All right, so then the next one starts to get complicated. X squared plus 6x plus 9 over 9 minus x squared. There's not much that is alike between those two, or at least it doesn't look like it. They both have a 9, they both have an x squared, but they're all in addition and subtractions. So sometimes in order to simplify, just like up here we had to factor a 5 out of the 5 minus 10x, when we have something more complicated, we might have to see if we can factor it. Which, if we look at the individual parts of this fraction, x squared plus 6x plus 9, going back to when we factored, in order to factor this, we check to see are both the first term and last term perfect squares, which x squared has a square root, which is x. 9 has a square root, which is 3. And 6x is the same thing as 2 times x times 3. So that fits into our perfect square trinomial. So that means that that can factor as x plus 3 squared. Or that's the same thing as x plus 3 times x plus 3. The other one, 9 minus x squared. If we look at that by itself, two terms separated by a subtraction with a square in it. So we check to see if those both have square roots. 9 has a square root, which is 3. X squared, of course, has a square root, which is x. So that is a difference of two squares, two perfect squares separated by a subtraction. So we can write that as 3 plus x, 3 minus x. Now, we have x plus 3 times x plus 3 over 3 plus x times 3 minus x. One thing we can recognize, since this is addition, we could rearrange that. So this is x plus 3 times x plus 3 over, we can swap places in addition. It doesn't cause any problems. X plus 3 times 3 minus x, which allows us to cancel out 1x plus 3 from the top and bottom. And we're left with an x plus 3 over a 3 minus x. And that is simplifying rational expressions.